Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. We are students from Diploma in Mathematical Science, CS143-4B from Group 4, has assigned to do video presentation for subject MAT263. So today, our group will present about system of linear equation. Before we start, let me introduce our group members. Introductions of linear equation. Linear equation is represented by x1, x2, x3, and xn is a variable, and where a1, a2, a3, and an are the coefficient, with b is a constant. Okay, next is about a system of linear equation. System of linear equation is usually a set of two linear equations with two variables x, y, or others. The way how do we determine the equation are linear or not is the linear equation cannot be involve product of two variables, and they cannot involve a trigonometric function. Next, a system of equation can be represented by augmented matrix, which is each row represents one equation in the system and each column represents a variable. By using this method, we can see augmented matrix are shorthand way of writing the system equation. Next, system of linear equation also can be represented in metric form using the coefficient matrix, a variable matrix, and a constant matrix.
Hi, Assalamualaikum. My name is FARIEZA binti MUSTAFA, and I would like to present about the methodology that we use to solve the problem of this chapter. There are two methods to solve this problem. First, elementary row operation ERO. We can use interchange, scaling, or elimination. First, interchange. Interchange row with another row. Second, scaling. Scaling is multiply one row with non-zero constant. And the third, elimination. Elimination add multiple of one row to a different row. There is no non-zero real number. Second method is Gauss-Jordan elimination. Gauss-Jordan elimination is reducing a matrix to reduce row echelon form (RREF) by performing ERO. There are 4 steps by use this method. Step 1. Write the given system linear equation as an augmented matrix. Step 2. Perform the ERO to put the matrix into RREF. Step 3. Convert the matrix back into a system of linear equation. And the last one, use back substitution to obtain all the answer.
Assalamualaikum warahmatullahi wabarakatuh. My name is ATHIRAH binti ROSLI, and my matrix number is 2021116509. For this group project, I'm going to present to you the purpose of study and the case study for this chapter, which is the second chapter. The first purpose of study is to find how matrix can represent a system of linear equation. The second purpose of studying this chapter is to solve the problem of linear equation in form of augmented matrix. Last but not least, this chapter helps to find the price of each product per box by using Gauss-Jordan elimination method in the case study. Now, I'm going to read the case study that we got for this chapter. Siti managed to join a dropship in Nuha Cosmetic for her EMT assignment for 3 weeks. On the first week, she restocked 1 box of lipstick, 1 box of setting spray, and restocked 2 boxes of eyeliner. The second week, she restocked 2 boxes of lipstick, 4 boxes of setting spray, and sell 3 boxes of eyeliner. The last week, she restocked 3 boxes of lipstick, 6 boxes of setting spray, and sold 5 boxes of eyeliner. So, the total money that she had for 3 weeks of doing the assignment is RM900, RM100, and RM20.
Okay, Assalamualaikum. My name is AZIMAH binti MOHAMMAD SHUIB. I will tell you about result and discussion. 1. Form an augmented matrix that represent the system of linear equation. Okay, firstly, we need to take out all of information from the question to create linear equation. After we have linear equation, we can find the augmented matrix. So this is how we find the augmented matrix. Okay, 2. The price of product per box by using Gauss-Jordan elimination method. We commute the first non-zero constant in the second and third row using Gauss-Jordan elimination method to form 0 under the leading entry of the first row. So the calculation will be R2 plus -1 minus R1 will become R2, and R3 plus -3 minus R1 will become R3. Okay, second, we need to commute the first non-zero constant in the second row using Gauss-Jordan elimination method to form 1 as the leading entry of the second row. The calculation will be 1 over 2 minus R2 will become R2. Okay, next, R1 plus -1 minus R2 will become R1, and R3 plus -3 minus R2 will become R3. To make leading 1, we calculate with 1 over -1 over 2 minus R3 will become R3. Okay, lastly, we commute the first non-zero constant in the first and second row using Gauss-Jordan elimination method to form 0 under the leading entry of the third row. So the calculation will be R1 plus -11 over 2 minus R3 will become R1, and R2 plus -7 over 2 minus R3 will become R2. Okay, the final answer will be X equal to 320, Y equal to 60, and Z equal to 260.
For conclusion, we use a system of linear equation by reducing its augment form. In this case study, we use the method of Gaussian-Jordan elimination to find the price of each product per box. Thank you for listening.